Hello and welcome to another one of Dee's ADD videos. Today we're going to look at the example of quantum numbers. Here we're going to look at going from a given set of 4 quantum numbers to the actual element on the periodic table. I'm going to look at both the positive 1/2 and the negative 1/2 and explain that to you. But if I were to give you a problem that had the principal quantum number of 3, the second quantum number of 1, the magnetic quantum number of 0, and the spin of positive 1/2, how would you approach trying to find what element this was? So if we were to look at that, well, we know we're on the third row because of that. We know we're in the p orbital because of that. And we know that we stop at 0 in the orientation space, and it's positive 1/2. So let's see it. Let's see it in action. So just looking at the third row, here's the S for the third. Here's the P. First one's going to be -1, then 0, then 1. Okay. So let's say I said 0 and it's positive, right? What does that mean to you? Well, what that should mean to you is that because we're in the p orbital, off-bow tells us S had to have been filled already. Then we know that because it's a positive 1/2, all the negative ones, the ones going down, have already been added. Oops, sorry about that. It's just a half an electron, or half an arrow. And then we started pairing up. And to end up with 0, that's what we have there. So what element is it? Well, again, this was positive 1/2, right? And it put us over here in the ups. And had it been a negative 1/2, what would have happened differently is we would have stopped on the first go round. It would have been only 2 electrons. So let's see. Let's look at our periodic table. So we have 2 in the third row and then 5 electrons in the p orbital. So 1, 2, 3, 4, 5 puts us at chlorine. Okay. Let's look at it if it was a negative 1/2. What if it was a negative 1/2? Let's get a different color here. Let's get raw umber. I have no idea what color that is. So let's say it's a negative 1/2. How would that look different? Well, we would still have the same basic divisions here, and when filling our electrons, let's see, let's get a different color, mauve blue. Interesting. All right, let's try that. So we still have, I don't know if you can see that. That's a little too non-visible. Let's go with something brighter. Cadmium 11. Got some crazy color names here. So we would have 1, 2, because S gets filled before P, right, off bow. And then here we need to end up in the 0, but we need to be going down. So that goes around on the first pass. We don't put one in the 1 and then start pairing up because it's a negative 1/2. So that would be 2 electrons in the p orbital, and that would be, let's see, 1, 2 silicon. So do you see how we're able to identify elements? Okay, this last part that I just gave you was kind of taking it one step further. For the intro part, you should be able to realize that there's one of these 4 combinations of quantum numbers possible. Okay, thanks to Pauli's exclusion principle. But then, as you get more familiar with these, you should be able to name an element based off the quantum numbers, or given quantum numbers, tell us the element. That's what I just said. I'm sorry, it's 3 a.m. I'm tired. Or given an element, write the 4 quantum numbers. Did I just say the same thing 3 times? I'm going to have to record, listen to the recording. Name the element given 4 quantum numbers, or give the 4 quantum numbers given the element. There you go. That's what I was looking for. Looks like I'm going to have to do some editing there. So practice, practice, practice. If this seems a little confusing to you, it shouldn't. After a little bit of marinating in your brain, it should start making sense. All right? Practice, practice, practice. Thank you and have a nice day.